Everyone, so now we are going to do the lab for NAT. So we are going to do the lab, three labs we are going to do. One will be for the static NAT, second will be for dynamic NAT, then fourth will be the PAT. So let's do the lab in the EVNG. So I will open the EVNG and we will do the lab in the EVNG. Theoretical concept we already learned, whatever the theory we discussed in our previous class. Now we have that idea, so now we need to do the lab. So let's do in the EVNG. Why we need NAT, network address translation? Because we cannot access the internet with the private IP. If we want to access the internet, we need to use the public IP. So what we will do, we will buy some public IP and we will map that one. For that purpose, we will use the NAT. So we can access the internet with the help of public IP, private IP to public IP. So let me go here to our CCNP labs. I will open new lab here. This one is the, I can give static NAT. So let's start here, static NAT. We can take any scenario. I will take two router. Let me take two router here. Here we can give quantity 2 and here the router name R, and interface we can add fast Ethernet, and let's say OK. We can say this is our home router, that is, this is our core router, so we can say this is our gateway. Okay, this is the gateway, and I will say this one is a ISP. Imagine this is a ISP router. We can take the NAT cloud also, but we will do another way. This way we will check our NAT is working or not. So what we will do, we will have one router here. This is the ISP. Imagine this is a service provider. Maybe your company is having one router that is a gateway which is connected with the ISP. ISP means internet service provider. He give you some IP. He told that you need to assign that IP to your interface where you are connecting the fiber cable coming from the ISP and point out one default route towards the ISP. So you done that one. And let's draw some internal network also. I will take one switch. I will take this switch. We will have some devices here. Let me take one switch. This is one switch I will take, and we will connect some devices to our switch. So this will be connected here. Okay, and then what we will do, this is a switch, so I will change the name, this one as a SW. Just I am creating one small scenario, and then we can take some PC. I can take VPC. Let me take the VPC. Let's see, where is VPC? This is the VPC. Let me take 3 PC. I will give the name PC, and here we can select the icon, which one you need. I will take this one. So I have 3 VPC. We can connect from here to here, and let me and rename this one PC1, and this one will be PC2. You can have n number of PC. Just I am taking here 1, 2 or 3 PCs. You can take lot of PC, whatever, depend upon the organization. This for lab purpose 3 PC are sufficient for us. So this we connected here. Now what we will do, we will configure the NAT here. Imagine this is a ISP router. Let me give the IP schema. We will write here 192.168.1.1/24, and let me increase this font size and give me bold, and any color we can take. Let me take this color. So this is the IP schema we are going to use inside. So this will be here for this machine will be 1.2, and for the other machine we will take this one will be 2.1.3. Here we will take 1.3, and after that we will take the other IP schema. Let me duplicate this one. Here we will have the 1.4. So these are the IP address we are going to use inside our network. And let me start the routers so it can boot up. Let me start the router, switch all the PCs. So it will be boot up and it will be ready. One by one we can start, or we can start at a time also. And here let me make this example. You get the public IP. Let me take this one as a 200.1.1.1. okay, this is a public IP ISP give you. They told assign this IP to this interface and forward the traffic towards this IP. ISP, when you buy the public IP, they will say that point the default route towards this IP. So this is a public IP from the ISP. This will be ISP side, this will be your side. You have the fiber cable, you connect to the router and you assign this public IP to the router and you put one default route towards the ISP. This way we will do. After that we will have example. Imagine we have the Google network here. We can say this is a google.com. I can write here. We can take the 8.8.8 this side. So this is our topology. Now we need to do the configuration. So let me open here this one, the console of this one. In real scenario for ISP router we will not do anything, okay, but in the lab purpose we will do for ISP router also. And this one I will open this VPC1, I will open the VPC2, I will open VPC3. So now what we will do, let me take the notepad, we will write the configuration here. First we will write, let me write here NAT, that is static NAT Lab, okay, static NAT Lab. Here I will write ISP configuration. In real scenario we will not do anything for the ISP, but here we are doing because this is a lab. So host name will be ISP, and then what we will do, we will do our interface. If you see interface fast Ethernet 0 by 0, we have the IP address 200.1.1.1 like this, 200.1.1.1, and the default, the subnet mask is 255.255.255.0, and we will write no shut. I am doing for here, so this is the 1.2. So let me change this as a 1.2. okay, what I done, just I assign the IP address. Then I will create one loopback and I will give the IP loopback 0, and I will write IP address 8.8.8.8. Imagine this is a Google what we can say, Google server. So this is our ISP configuration, the basic configuration. Now we will do our gateway. This is a gateway configuration. So here what we will do, same thing as we done, enable, then config t, host name GW, and the interface fast Ethernet 0 by 0. I will write here IP address. Let me copy this from here to here. We can paste here, we can modify as per our requirement. This will be 1. And we have one more interface. That interface will be interface fast Ethernet 1 by 0, and then we write IP address. I will write 192.168.1.1 255.255.255.0, and we will write no shut this one. Okay, and ISP told give one default route. Whenever we configure, whenever we connect it to ISP, we need to create one default route towards the ISP. So this is a ISP, so we need to point one default route. How we can point? We will write here IP route and then 0.0.0, and then we will give space and we will write here space, then 0.0. Let me write here 0.0.0, give space and write the, what we will write, we will write this IP, because we need to forward all traffic here. So we will write 200.1.1.2. Okay, so what we done the default route here. What we done the default route. We are saying with any traffic, with any subnet mask, with any IP, with any subnet mask, forward to this IP. Okay, so let's copy paste this one. I will copy and we will go in the console of the G, that is gateway, and we will paste here. I will paste here this one. Okay, so this one is good. We can save if you want. We can save, do WR to save the configuration. Now I will paste this one in the ISP router. So let's go to ISP router. Where is ISP? This one. So this one I will make big and I will paste here. Okay, so I paste this one. Everything is good. If you want to save, we will save WR to save the configuration. Now what we need to do, we need to assign the IP here. So let's take the PC1. Where is the PC1? We will assign the IP 192.168.1.1, 1.2, 1.2/24 space 192.168.1.1. Okay, enter. So this way we will assign the IP address. Then we will write show IP. So we get the IP correctly. I will save this one. This is our IP address and this is our gateway. So now we will do for the another PC, the PC2. I will go here. I will write IP 192.168.1.3/24 and then 192.168.1.1, and we can check, and I will save show IP, and then we already saved, so this is also good. Now I will go for the last PC, that is a PC3. I will assign the IP here, IP 192.168.1. This IP is 4, I think. Let's see what I wrote here. 1.4/24 space 192.168.1.1, and then I will write here. I will save and then show IP. So everything is good here. Let's see. I can ping 8.8.8.8 request timeout. Okay, request timeout. I cannot ping. Why I cannot ping? Because our request is going in this way. What I am doing, I am pinging the internet. So this IP is coming here, and here this private IP. This is a private IP. In the internet, ISP block the private IP. They have the access list that will drop the traffic. That will drop the traffic of this one. So it will drop because private IP cannot go on the internet. So whenever this IP is trying to go outside, our ISP router is having the ACL, they will drop the private IP because they cannot track. Private IP is using all the guys. Example, I am using 192.168.1.1. You are also using. All the guys are using in the home network, in anywhere inside organization also they are using. If all private IP go on the internet, ISP will be confused. This belongs to whom? So what they will do, they will block the private IP. So this will not go to the internet. So what we need to do, we need to configure the NAT here. We need to configure NAT. NAT is having 3 types, that is a static NAT, dynamic NAT, and the PAT. So we can configure any one here. So our IP will convert from the private to public, and he can go outside and bring the whatever data we are fetching, bring back to our PC. So how we will configure, let's see now. Okay, so we need to configure in the gateway. Gateway means this router. We need to configure in our gateway. So here I can write, let me write the step here. We can write IP NAT inside source. Let me correct the mistake here. Inside IP NAT inside source static, because we are going to use a static NAT 192.168.1.1. Static NAT means one-to-one mapping. If you remember, before we told, when we configure the static NAT, we need to map one-to-one. Example, if we buy the public IP, imagine we buy the public IP 200.1.1.1, and maybe we will buy 200.1.1.2 used by ISP, so 3 200.1.1.4. so we can map this IP to this IP. I will map here like this way: 192.168.1.2, 192.168.1.3, this one, and then 192.168.1.4. so this way I will map in the static NAT. So now I am doing the static NAT, so I need to map one by one. So what I will do here, I will write here, let me move here, we will write here IP NAT inside source static. This one need to map to new one. Which one need to map? This one, 1.2. so I will change this as a 1.2. 1.2 need to map to 200.1.1.3. okay, I will say map this one to this public IP. This is public IP. Here we are using, we assign here, and one more we have here. This is assigned to our router, this is assigned to ISP router. We buy, example, we buy 3 IP or 4 IP we buy from the ISP. That is 200.1.1.1, 200.1.1.3, 200.1.1.4, 200.1.1.5, like this. So our 5 machine can access the internet. So how we will configure? Same thing. I will paste the steps 3 times, and we will put one time this IP, second time this IP, third time this IP. So I will put this 3. Here will be 4, and here will be 4 and 5. We buy 3 IP: 200.1.1.1, 200.1.1.3, 1.1.4, 1.1.5. So we are saying IP NAT inside source static, convert this to this. After that we need to apply the NAT. How we will apply the NAT? We will write here interface. We need to go interface. If you see, this is an interface fast Ethernet 0/0. So what we need to write? Interface fast Ethernet 0/0. After that we will write IP NAT, and if you see here, traffic is going like this way to this interface inside, going inside the router. For this interface, leaving outside, so outside the router. So what I can write here in this place, IP NAT, and then I can write here outside, and then we have in interface fast Ethernet 1/0 IP NAT inside. Okay, so we can do this way. So this is only the configuration. Now let's copy and paste and check. I will copy this whole thing. Okay, and then we will go in the gateway. This is the gateway here, and duplex mismatch is coming because we are using the switch. Switch is having full duplex. So what I can do, I can go to the switch here, I can change the interface, or I can go to the router also, but anyhow let me change here in the switch. I hope you remember how we can change. In EVNG we have this issue. So I will go interface E0/0 duplex half. That's all. If we do this one, we will not have that issue. So I done already. Now let's check in our router gateway. We will not have this issue now because all are half duplex. So now I need to paste the configuration. So let me copy. I think I already copied, but anyhow let me copy this configuration and paste here. So I paste, no error. It is pasting still. Let me check here. It hang or yeah. So everything is good here. No issue. Let me check all interface is up or not. Show IP interface brief. So here we assign 2 interface. Something wrong maybe before. Let me check what I paste here. Why same IP 2 times, and how it assigned 2 times? We cannot assign the same IP to the 2 interface. Something issue in this what we can say in this router. Anyhow let me check where it is assigned. Fast Ethernet 0/0. Okay, this one we are using, and this is fast Ethernet 1/0. This is okay. This is not that one. This is separate thing. I am thinking here. I am thinking this one. Okay, so no issue. I paste already. Now we can ping. Let's go here. I can go to the PC one. Let me check I can ping or not. Before I cannot ping. Let's see. Ping 8.8.8.8. Okay, first time is request timeout, second is working. So now it is working. PC1 is working. I will go for the PC2. Let me ping here. Ping 8.8.8.8. First packet will be dropped for the ARP address resolution protocol, and then let me go for the other PC3. It will work here also. Before it is not working, it will work now. If we connect one more PC, then it will not work because we only map 3 IP. Okay, what I am saying, it is working here perfectly. Okay, now if I bring one more PC and connect to this switch, then it will not work. If you want, we can try also. Let me save this configuration in this switch. Here I will write WR, and now I can take one PC here, VPC. Where is the VPC? This one. Here I will give PC. What is the name here? PC4. Icon, we can change any icon. Let me take this one. And I need to switch off this one because I cannot connect in the EVNG. I need to switch off machine, then only I can connect. So I will connect. All interface already used, so we need to increase the interface here. How we can increase the interface? Here we can put 2. Okay, but sometime they are giving issue also if we increase the interface. Now let me connect here. Okay, it is having now this one, so I will connect this interface. So this is okay. Now I can start this switch, and after that let me start this PC also, and this PC schema I will give here this side 1.5. okay, 1.5, and then I will open the console of this machine. I will assign the IP here, IP 192.168.1.5/24 space 192.168.1.1. then we will save the configuration. I will save the configuration, and then I can ping 8.8.8.8. It will not work because we did not map here. If you see here, we have only mapping for 1.2, 1.3, 1.4. If we change the IP address of this machine, then he can go to the internet. If it did not change, it will not work because this is a static. Static means 1-to-1. Okay, if we use the dynamic, then this guy will work. Example, these 3 guys are accessing, and after some time this first PC is not accessing the internet, then the other remaining PC start working. That is a dynamic NAT. So now what we can say, this is a static NAT. We check our machine is going, and also we have here, we can check in our gateway. We can go to our gateway and we can write show IP NAT translation. Here we will get the translation. What we are getting, this is our local IP, that is our inside network here. This IP 192.168.1.2 is translating to 200.1.1.3 to go outside, and this IP 1.3 is translating to 1.1.4, and this IP is translating to 200.1.1.5. Let me again ping any one machine, and let's see. I ping this one, and PC, this one also I will ping, and I will ping the other machine also, this one. Now let me type again here. Let's see here. Yeah, see, now we have the more record when we are pinging, because after section expire, the entry will go outside. So what we are doing the ICMP. Okay, and this is our internal PC. Internal PC IP is this one, and our PC is generating random port. So this is a random port added, and it is going. They will store in the NAT table, saying that this private IP with this port number is translating to this public IP with this port number, and they are going outside to the internet, and they are coming back from there, and they will return back the traffic. So same entry we have. This is a 1.2, and if you have 1.3, If you have 1.4, how they are translating? They are translating same IP 1.3, 1.2 with this one IP only, this IP, but they are putting the port number here. This one, let me show you, from here to here is 1.2. 1.2 is reserved for 1.3, and if you see here to here, 1.3 is reserved for 1.4, and if you see here, 1.4 is reserved for 1.5. So one-to-one mapping in the static. But if we take for dynamic, or if we take the PAT port address translation, in that one, whatever is available, one IP is going to use one IP, that is one public IP is going to use for all the sources. But here, if you check, 1.2 is reserved for 200.1.1.3, and 1.3 is reserved for 200.1.1.4, and if you see 1.4 is this one is reserved for 200.1.1.5. One-to-one mapping. This is known as static NAT. But for the dynamic NAT, whoever is available, they will take. For the PAT, we will have only one public IP, and all the guys is going to internet with one public IP. So let me stop the recording. This is a static